Hi, everybody. This is the beginning of Chapter 3. We're going to look at Section 3.1 and talk about lines and angles. So again, Section 3.1, we're going to start talking about lines and angle relationships between those lines. All right, so we're going to start off and just look at different types of lines. Mainly within this chapter, we're going to talk about parallel lines. We will look at some perpendicular lines, but these are other good definitions as well. We have parallel lines, and just a reminder, parallel lines are coplanar lines, so they have to be in the same plane, that never intersect. The two straight lines, so like this, mean parallel lines, or if you see lines with the arrows on both of them, it also denotes the parallel lines. Next, we have skew lines. Skew lines are non-coplanar, so they're not in the same plane, they're not parallel, and they don't intersect. We won't really, other than mention them right now, we won't really talk about skew lines. Next, we have parallel planes. Remember, planes, kind of think of like the sheet of paper. They are two planes that are parallel to each other. Okay, so here we're just going to look at the rectangular prism that we have on the right-hand side of the page and compare things to the line GH. So they want you to answer the question. They want you to ask or answer, and I want you guys to try this, so maybe turn it off, just try it first and then come back. Can you identify lines that are parallel to GH? And remember, parallel lines have to be in the same plane. So when I'm looking here, let's see, I think that, let me put my highlighter on here. Okay, parallel to GH. Well, CD, so line CD is parallel to GH. But then also, if we look following this plane right here, EF is parallel to GH. And then we also have another one, and this one's a little bit harder to see. So if we imagine a plane running diagonal through this rectangular solid, we can also say that AB, so the plane would have to go down through here, that AB is parallel to GH. All right, now we need to know which lines are skew to GH. So let me go ahead and erase this. And which lines are skew to GH? So they can't go through the same plane. And they also have to pass through point A. So here is point A. So skew lines that are skew to GH, so they won't intersect and they're not in the same plane, would be, but they go through A. If we look here, we have line AD. That's in a different plane than GH. So line AD. And then also, let's see here. I believe line AE. If we look at this, and again, it has to go through, so that's never going to touch. It's not in the same plane as GH, so AE. And those are our only two skew lines that pass through A and that are skew to GH. Any lines that are perpendicular to GH, so that meets it at a 90-degree angle. And here, again, this is something that we don't like to do, but because it is a rectangular prism, we know that they're going to meet at 90-degree angles. So that means that line DH, let me erase real quick, DH maybe I won't erase. I can't seem to get it to work. Okay, but DH is perpendicular to GH. CG would be perpendicular, but then also coming in from the side. So EH and FG, all of those lines are perpendicular to GH. And then the last thing we want to do is name any plane that is parallel to CD HG, and if we highlight CDHG, it's this plane right here. So parallel to that plane would be, we could say plane ABFE, and let's see here, any other planes? No, that would be it, just that plane right there, ABFE. Those are parallel planes. All right, now we've mainly talked about parallel lines or skew lines, but we can also have segments that are parallel. So again, parts of the line. If segments are parallel, then if you were to extend out those segments and make them lines, they would also be parallel. And then non-parallel segments, so these right here are your parallel segments. So if segments are parallel, the lines would also be parallel. But if the segments are not parallel, then at some point, even if they don't intersect when the segments are drawn, they would, when you extend them out, intersect at a point. All right, a lot of times in this section, in this chapter, we're going to talk about lines cut by a transversal. Mainly we'll look at parallel lines, but today we're just going to talk about any two lines cut by a transversal. And a transversal is a line that intersects two or more coplanar lines at different points. And when a transversal intersects two lines, then 8 different angles are formed. And the important thing to note here, and we're going to talk about, is we're going to have an interior part. So between the two lines is going to be interior angles that are formed. And then outside the two lines, those are your exterior angles. And here's just another picture showing you the interior and the exterior angles. Again, interior means inside, exterior is outside. All right, so here we're going to be talking about different angle relationships based on two lines cut by a transversal. The first angle relationship we're going to talk about is alternate interior angles. Alternate interior angles are angles that are non-adjacent interior angles that lie on the opposite sides of the transversal. So when I think alternate, I think they jump over the transversal. Interior means they have to be on the inside of the angle. So for instance, angle 3 and angle 5, that would be an alternate interior pair. And then also angle 4 and angle 6 would be another pair of alternate interior angles. Next, we have same side interior angles, and those are interior angles that lie on the same side of the transversal. So think interior angles on the same side of the transversal. So for instance, here, angles 4 and 5 are both on the same side of the transversal. And then, so that would be one pair of same side interior angles, or consecutive interior angles. And then 3 and 6 are both on the same side of the transversal on the inside. So they would be another pair. All right, now we're going to talk about corresponding angles. And I want you to imagine if we were to take our two lines cut by a transversal and we were to cut it through the middle there. So cut it through the middle. And if I were to take the top angles and lay them on the bottom ones, this would be your corresponding pairs. So angle 1 is in the top left corner. Angle 5 is also in the top left corner if you were looking at it as two separate things. So if I were to put the angles on top of each other, 1 would be on top of 5. So 1 and 5 are corresponding angles. And then 4 is on the bottom left, and so is 8. So that would be another pair of corresponding angles. The same with 2 and 6. They're both on the upper right. They're a pair of corresponding angles. And then 3 and 7 are also a pair of corresponding angles. Okay, and the next type of interior, or not interior angles, but angles we're going to talk about are alternate exterior angles. So think exterior, it's going to be on the outside. Alternate, again, I want you to think they're going to jump over that transversal. So we have on the outside angle 2, and then I have to go down to the bottom for the other outside angles, but I want to jump over my transversal. So angle 8. 2 and 8 form a pair of alternate exterior angles. As do, if we look here, we have angle 1 and angle 7, and that forms another pair of alternate exterior angles. Okay, so here they want us to list all the angle pairs in the figure. So they first want alternate interior angles. And what we need to do is identify what are the two lines being cut by the transversal. So here, M and N are my two lines, and then there's T is the transversal. So alternate interior, remember interior is on the inside. So if we look, an angle that's on the inside is angle 8. And then it is an alternate interior angle to angle 5. So angle 8 and angle 5 are one alternate interior pair. And then we also have angle 3 here, and it is alternate interior to angle 2. So that's one other pair of alternate interior angles. Those are the only two pairs. Okay, now we are going to look at corresponding angles. So again, if I were to cut this in half right here and take these angles and lay them on top of these, what would match up? So I know that 7 is right here in the upper left, so angle 7 and angle 3 is one pair of corresponding angles. Then 8 and 4, so angle 8 plus angle 4 is another pair. And then on the bottom left, we have angle 1 plus angle 5. And our last pair would be angle 2 and angle 6. Those are your 4 pairs of corresponding angles. All right, and our last question of this section shows, we have a photo showing the Hearst Building in New York City. It was completed in 2006. So they want us to fill in the blank. Angles 1 and 5. So if we look here, let me do this. Let's see. Angle 1 is right here. Angle 5 is right here. What kind of angles are they? And if we look, they're outside my parallel lines, and they alternate the transversal. So that means that they are alternate not interior, but exterior angles, because they are outside that transversal. Okay. Next, we have angles 2 and 7. So 2 is right here, 7 is right there. All right, there's 2 and there's 7. They are both inside the parallel lines, or the lines, and they're on the same side of the transversal. So those would be then same side interior angles. And that is it for Chapter 3, Section 1. Have a great day, guys. Bye.